Welcome back to the channel, bug friends. Today I wanted to talk about some fossils. This is an article that was just published coming out of Canada in the Canadian Journal of Earth Sciences, but it's about insects. And it seems that in Alberta, in the Dinosaur Park Formation, there was a recent discovery of a fossilized wing of an unknown odonate, so an unknown dragonfly. And this is the first of its kind for Canada. Possibly more excitingly, this was discovered completely accidentally. This was a field trip by a bunch of undergraduates looking for dinosaur bones and leaf fossils, and they accidentally, while looking for these leaf fossils, leaf impressions, split open a rock and discovered a first of its kind insect impression in this large, very famous Canadian fossil formation. So Dinosaur Park is in Alberta here on the map that you can see. And where this particular fossil was found was up on this cliff formation called Minas Tirith, which is a pretty great name for a fossil formation or a rock formation. And the fossil itself was found down here in layer 2. So towards the bottom of this formation, they were splitting open rocks when they accidentally found this very unique fossil. And I keep saying unique because it's actually from this fossil is its own family now. So this is up until this point not just an unknown species, but an unknown family of dragonflies that were active during the Cretaceous. So this fossil is from about 75 million years ago, so during the time of the dinosaurs. And this is what they found. So this is an undergrad holding this rock. Very, very small rock. You think, oh, that's not very impressive. But it's because this is actually only a section of the hind wing. So this is a proximal section. So the body would have been here. And so you end up with, proximal, so close to the body. This is a section of the hind wing close to the body. And this is what it would have looked like in life. So you see all of the cross-venation. So obviously some sort of dragonfly or mayfly sort of insect or griffinfly, which are now all extinct. But there is no dragonfly currently extant or known from the fossils with this particular arrangement. The identification concentrates largely on this anal loop section here. So they knew that this was not something that had been seen before. They named the new family Chordula density, and the new species is named Chordula densa acorni, which is also interesting if you know who John Acorn is. So John Acorn is an entomologist, biologist, paleontologist that works in Alberta. He used to have a television show called Acorn the Nature Nut, I believe. And it was kind of like the Canadian version of Bill Nye the Science Guy, but for biology. So the species was named after him, which is kind of nice. I met him years ago. I spent several days with him. Super nice, super knowledgeable. He's worked extensively on things like tiger beetles and has written many books on various Canadian biology subjects. But this is a really neat find that, even if you're an undergraduate, you're not, a professional paleontologist, this is something that you could always stumble upon. This sort of discovery has totally revolutionized what it is that they're looking for in this dinosaur park formation. Up until now, they've only ever found one insect in the entire park, and it was an aphid preserved in amber. So now they are going to begin looking through the stone layers for more impression fossils. You can see on this diagram here what they were expecting to find. There are vertebrate bones and leaves, and occasionally they were thinking maybe some insects in these fossil formations. Down here on layer 2 is where they found the dragonfly. But now that they know that this sort of fossil is found in this sandstone and in this siltstone, they are going to start looking more seriously for this type of insect fossil. So hopefully they find more and they can really expand what we know about the Cretaceous. This particular find filled in a very large 30 million year gap for the North American dragonfly species. So this is a relatively big find. It's unfortunate that it's such a small fossil, but generally speaking, insect impression fossils are extremely rare because insects don't preserve well in stone formations. Most of them are found in amber formations. So with that, I will link to both the press release and the research article if you want to read them, and I'll talk to you guys later.